Okay, so today we're going to do day 6, 6.4, solving systems of linear equations with substitution. Today's learning goal is I can solve a system of linear equations using the substitution method. So remember, we've taken care of one method, which has been graphing. We did that the other day. The second one that we're going to look at is substitution, which is today's lesson. So these are different methods of solving a system of linear equations. Again, remember some key things. We always want to have an ordered pair of x, y for our solutions. So you can solve linear systems using an algebraic method called the substitution method. Solve one of the equations for one of the variables, then substitute the expression for the variable into the other equation and solve for the second variable. Solve the system by substitution. So we're going to take this one a little slow. So in the first equation, I'm going to go ahead and number that. Equation 1 and equation 2. So in the first equation, it reads y equals 3x. The second equation reads 2x plus y equals 15. Well, with the substitution method, we're going to look at each equation and notice how each equation has a y in it. Well, for each equation, notice that this equation here, y equals 3x. So we already know that y is going to equal to 3x. And in equation 2, we have the equation 2x plus y equals 15. Well, because I've already solved for one variable, y equals 3x, I can take that information from 1 and plug it in for the y in equation 2. So ultimately, that would look like this. Could take the information, so I'm going to rewrite equation 2, which says 2x plus, and then I'm going to substitute what y equals. Well, I know y equals 3x, and then equals 15. So only thing I did was took the information in y and substituted it in for the y for equation 2. So taking equation 1 and substituting it in for equation 2. Now I can just solve for my variable of x. So 2x plus 3x, they're like terms. So that gives me 5x equals 15. Solving for x, I have to divide by 5 on both sides. Those cancel. So I get x equals 3. Well, that gives me one part of my ordered pair, which is the first part. Tells me that x is 3. But then I have to find the second part, which is the y portion. Well, out of your equations, equation 1 and equation 2, you get to decide which equation you would like to use to substitute your findings of x to find y. So let's try using the first equation. So the first equation says y equals 3x. Remember, I know exactly what x is, and my goal is to find y. So I have y equals 3. I'm going to substitute the value of x in for this x here. So I have 3. That's what x was. So I'm letting x equal 3. And I can solve for y now. So I have y equals 3 times 3 is 9. So I just found the other portion to my ordered pair. So when it says solve the system by substituting, the solution to these equations here, to this system, is 3, 9. Let's look at another one. Solve the system using substitution. Check your answer. So again, remember, let's go ahead and number our equations. So 1 is the first equation, 2 is the second equation. So we're still using the substitution method. So I already noticed that my equation has y equals some expression. So I know that I can match my y with the y in the second equation. So where I see the y in the second equation, I'm going to plug in this information of x plus 3. So my equation should now read 2x, so I'm substituting equation 1 into equation 2. So I have 2x plus 2. My y equals x plus 3. and then I'm going to go back to equals 38. So all I did was take everything in y, what y equals, and plug it into my equation here. So it's just a substitution method. Now I can do some math. So I have 2x plus, remember distributive property, 2 times x gives me 2x, and then 2 times positive 3 gives me a positive 6 equals 38. Now I can combine my like terms. 2x plus 2x is 4x plus 6 equals 38. So remember, solving one-step equations or two-step equations, take the inverse of positive 6, which is negative 6, from both sides. So I have 4x, these cancel, equals 32. Then I can divide 4 on both sides, so I can solve for x. These cancel, and I'm left with x equals 8. So I found one of the ordered pairs, which is which is x. Now I need to find the other portion of the ordered pair, which is y. So I'm going to you choose again which equation you would like to use. I'm going to choose equation 1 to substitute 8 in for x so that I can figure out what y is. So my equation is y equals x plus 3. Remember, y equals, I'm going to substitute x in, which we found to be 8, plus 3, just letting x equal 8. So y is going to equal 11. So I just found my second portion to my ordered pair, which means the solution to my two systems of equations is 8, 11. Okay, so we're going to do this one in class. Try to see if you can do it on your own. Wildlife biologists studied the weight of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown in the table. After how many months did the alligator weigh the same amount? What is the amount that they weighed? So let's look at what the question is. They want to know after how many months did the alligators weigh the same? And then they also want to know what is the amount that they weighed. So we have 2 questions we need to answer here. Well, if you remember us doing this exact same problem in 6.1 lesson, we found in our equation that our equations would be W equals, well, let's write what the alligator was. So alligator 1 had an equation that was W equals 4 plus 1.5 t. And then the equation for alligator 2 was W equals 6 plus 1t. So we set up these equations in 6.1, and so the yellow question that we have is after how many months did the alligators weigh the same amount? So we're going to set each alligator equal to each other. So we're going to take the alligators and set them equal to each other, which would read, we're going to take alligator 1, which is 4 plus 1.5t equal to alligator 2, which is 6 plus 1t. And by doing so, we can solve this equation for t. And t, remember, t represents the time or our rate. So let's solve this out. So first, I want to make sure that my variable is on one side and my whole numbers are on the other. So let's first get rid of let's make our variable be on the left side this time. So by doing so, I'm going to subtract 4 on both sides. that means that these two items cancel, and I'm left with 1.5 t equals negative 2 plus 1t. The next step would be to subtract 1t on both sides, because I ultimately want to have the value of the variable on the left side and the whole numbers on the other. So 1.5 t minus 1 sorry guys, we had some errors here. This should be a positive 2. 6 minus 4 is positive 2. And then again, we're going to subtract 1 from each side. That gives us 0.5t equals 2, because those cancel. Divide each side by 0.5 so that we can get t by itself. So t is going to equal 4 months. So we found out our yellow portion, which was asking us to find how long or how many months did the alligators weigh the same. They weighed the same at the 4th month. Well, now the second part says what is the amount that they weighed. So again, you choose which equation you would like to use, alligator 1 or alligator 2. I'm going to choose to use alligator 1's equation. Well, alligator 1 Alligator 1's equation said W equals 4 plus 1.5t. And I know exactly what t is, so I'm going to have W equals 4 plus 1.5. I know t is 4, so I substitute t in, and I solve for W. So 4 plus 1.5 times 4 gives me 10 pounds. So that tells me that my W, my amount that they weighed, was 10 pounds. So I just answered my question in green. So I want you all to try this one. Remember, we did this in 6.1. We set up this equation. See if you can figure out the question that it's asking. The first one, it asks you, what age did the spine dog shark and the Greenland shark be the same length? And the second equation is, what is that length? So I want you guys to try that, and we'll talk about it in class tomorrow. If you have any questions, please be ready to ask questions on tomorrow during class. See you guys later.